Danke, Stefan. Ja. Danke. Hey. So I switched topics from electric car to the regular combustion engine. Can you talk about that a bit?
Absolutely, Ramon. So combustion engines, internal combustion engines, will combine a mixture of air and fuel inside of a cylinder and compress this mixture. When it's ignited, the mechanical power produced is transferred to the vehicle powertrain by the piston. Now, after the combustion is complete, the piston will clear the cylinder of the exhaust gas, and this cycle repeats itself over and over again.
Okay, so shall we dive into some application? We talked about the role of the software, and you're still in the mechanical world, so how does software fit into the whole scenario?
Sure, well, our engineers, our customers, they use the LabVIEW graphical system design platform to optimize the performance of the engine combustion around a combination of goals for fuel economy or emissions and power production. Okay, so they do this by using LabVIEW running on the Compact Rio FPGA to precisely track the position of the pistons inside each cylinder with microsecond resolution. They then use LabVIEW running on the Compact Rio microprocessor to, in real time, calculate updated fueling strategies to meet the performance goals given the current operating state of the engine.
So when you say LabVIEW and Compact Rio, and we are in the automotive side of things, the I/Os certainly look different than the regular I/Os that we have. So do we have special I/Os for that?
We do. What our customers will use is the driven C-Series modules to interface to the sensors and actuators of an engine. So maybe a direct fuel injector or emission sensors. And I'm very excited to announce to this audience that these modules have recently achieved a CE marking. So they're available and ready to use in the German automotive industry now.
Perfect. So let's get back again. We talked about software, and if you're driving a car and there is more and more software inside, and in the US you'll be driving maximum 65 miles per hour. Here it'll be 200 kilometers per hour, and then you find bugs in there. So what happens then? How do we make the software secure?
Well, I think everyone in this room understands the complexities of developing software. And when that software is controlling a physical system, the consequences of a bug can be very, very serious. So last year, we actually talked about the growing use of embedded software in these mechanical systems. And we presented research that basically said that engineers should expect 10 to 20 defects per 1,000 lines of code produced. Now, given the amount of software being used in these systems, this is quite a challenge for our customers.
So what type of principles do we use to make the software secure?
Sure. Well, the V diagram is commonly used to illustrate the process by which this software and the software for these systems is developed. Now, for this particular topic, the key thing to recognize in the V diagram is that the software is actually being tested throughout the entire process, first in simulation, then in prototype testing, and then finally through a series of tests after the software is deployed to the hardware and integrated into the system.
Okay, so the V diagram is known here. So basically, you test early on the V, and you test as much as possible. So I mean, that's the state of the art. Right. Anything beyond that?
Well, yes. So in order to stay ahead of these complexities and to meet the timeline and budget goals that the market requires, engineers need to do more than just test early. They really need more efficient, better ways to collaborate throughout the entire development cycle. So here to talk with us more about what we're doing to help make this better for our customers, please join me in welcoming Meg Self, the Vice President of Complex Embedded Systems for IBM's Rational Group.
Hello, Meg. Good to have you in Germany. So how does IBM get involved in the whole thing, and how are we collaborating, NI and IBM, to make things better?
Thanks for having us. We're really excited to be here. Excuse my voice. From a perspective of IBM, the business unit that I'm responsible for, we actually deal with product development of our clients, so non-IT, actually systems engineering. So any industry where somebody is building something, making something, and handling all of this software, we provide tools, we provide processes, methodologies, as well as integrations and services that matter so that they can handle the complexity. As we've talked about, you mentioned it, we've talked about it through the whole conference. Complexity is something our clients have to manage. And so our clients, just like your clients, our mutual clients, have been talking about it and talking about how do they not only handle it, but master it, and how do they get in front of it. And so integrations all of a sudden become really important, and integrations of the development cycle become important. And we've seen insurgence of our clients talking about the integration of from a design perspective all the way through to test. And there's been a breakage. So that's a net new thinking, and it's really so that they can get ahead of the curve. For us, we heard this loud and clear from our clients, and to be able to start to chip away and start to make progress and bring solutions to the market that matter, we really wanted to partner with an industry leader on that right side of the V, so that we would be able to together really start to collaborate and start really to bring those integrations to bear that our clients need. We are starting to forge that collaboration together and starting to fuse and integrate our platforms. And with that integration, we're starting to handle and take out those manual processes and the breakages and starting to be able to put some automation in place and integrations that allow them to get ahead of that curve.
Perfect. So you described it very in detail. Let's illustrate this because we are at VIP Virtual Instrument in Practice. So let's put that into practice. Can you show us something to illustrate the points?
Yeah, so to be able to do this, we decided we wanted to really collaborate and forge a partnership that was really based on so a technical partnership. So we put together a prototype, and that prototype really was to illustrate how would we do the integrations and where would we stop and start and what we would do with the particular use cases and how would we perfect the particular interfaces. So what, Chris, you're going to start to show everybody is really the work in process. We're just getting started, but it's starting to show some of those integrations. And although this is an automotive example, it really would be applicable to any industry that has product development as the core.
Yeah, absolutely. So for illustration purposes, we have a demonstration where the engineering team is developing an adaptive speed control unit that's intended to operate across a variety of vehicle platforms. All right, and so we've captured the requirements for this device in the rational doors environment here, and we can see them organized across their various vehicle platforms there. Now, directly from inside of the rational doors environment, we can jump right into the IBM Rational Quality Manager to see the test case that is used to verify that particular requirement. All right, so now where we're at is we're inside of IBM's Rational Quality Manager, and we're at the test case, which is really the first example of where our two tools are being integrated to improve the experience for our joint customers. And so right from within this test case, we've effectively checked in the test components that are being used to implement that test case that verifies that requirement. So in this case, it's a Veristand sequence that's calling an NI-Veristand simulation there. And this is probably, I would say, one of the most significant things because prior to this, it was spreadsheets and other types of things.
Exactly. So from previous to this in our collaboration, it would be a manual process, like you said, spreadsheets that would be typically employed to be able to actually take the test components and link them back to the requirements in the quality plan. And now, together with the collaboration that we're showing here, we're able to actually provide an automated, managed link between the two, which really does start to handle the complexity and provide efficiencies and traceability.
That's right, that's right. And so this traceability, it can be very powerful. So for example, Manuel has already jumped here to a user-specific dashboard, which allows them to instantly get details about the status of their project. Now this particular dashboard appears to be for a member of the software development team. And we can see here that there's a series of defects that have been assigned to this person based on test failures. Now, these defects are another example of the integration now of our two platforms. Right from this defect record, this engineer has instant and flawless access to all the information they need to begin to diagnose and resolve this issue. This includes the test execution record that is produced by the NI-Veristand sequence. It also includes the process data that was performed by Diadem to generate these graphic reports, as well as the NI-Veristand files that were used to actually produce this data so they could recreate the test. So this particular issue appears to be related to a software calibration. We see here that we've exceeded the safety margin for our speed given the desired set point.
So let's fast forward a bit. So the software engineer finds the bugs and comes up with a new revision of the software, and then what happens?
Well, as we all know when you make a change in software to fix a bug, you can very easily create other issues in the software. And so what you really need to do is go back and re-verify any of the requirements or pieces of the software that may have been affected by that software change.
Exactly, and I think that really the most time-consuming thing, we all know that, the most time-consuming thing that the test engineering teams have is this exact thing. And that now with the collaboration and the integration, we're virtually eliminating the impact of that kind of a manual process.
That's right, and so we want to show you today in a demonstration here how we're doing that. And so to do this, we have 6 PXI-based hardware-in-the-loop test systems, and they're connected to 6 of our adaptive speed control units here. All right, and so what we've done with each of these is we've actually registered them inside of the IBM Rational Quality Manager as test assets or test resources. And what this allows the Rational Quality Manager product to do is then automatically find available test systems and deploy tests. So where this becomes very powerful is, as you can see here, Manuel has opened up a test suite which includes all of the tests, or the highest risk tests, that might have been affected by the software change used to resolve that previous bug. And so by deploying this test suite as he has, the Rational Quality Manager is going out, finding all of the available test systems that can run that test case, deploying that test case, and when it does that over the network, each one of these will take a test and sequence, and the test and sequence will upload the latest version of the firmware, the software, onto our unit under test. It will then invoke an NI-Veristan real-time HIL simulation to exercise our unit under test. And then the data collected by NI-Veristan will be automatically processed by Veristan. And to wrap it all up, the test and sequence will take all of that information and pass it back to the quality manager to be instantly available to the appropriate team members.
Perfect. So I think our customers would very much appreciate this collaboration, and I think we are looking into how this is going to continue. And maybe at next VIP, we'll see some user solutions coming from our customers. So I'd like to thank you for presenting this and the start of a great partnership.
Yeah, thank you. We're really excited about what this means for our clients, our joint clients, because what it really does is it starts to give them traceability, visibility, and automation in places where they had breakages. And what I'm really excited about is this is just the beginning of the partnership that we have together. And it is not just a business partnership, it's a technical partnership. And I think that's what will make the impact for our clients.
Wonderful. Thank you, Meg. Thank you, Chris.
Thank you.
Let's continue.
Thank you.